Can we hear me now? Excellent. Hi, I am so excited to be here. Um, and let's talk. This when we I tweaked the title of my talk just a little bit because when we originally planned this, it was very past, present, future, and I thought, okay, I get to talk about the present, which I do feel like if it's right what's in front of us, it's just always. I might be talking forever, or possibly just about 25 minutes. We'll see. Traditional second slide time. I'm Bridget Kromhout. If I don't look familiar, but my voice sounds familiar, you may have heard me on the Arrested DevOps podcast, which I co-host. I do cloud developer advocacy for Microsoft. I am the head of the Global DevOps Days organization. You just had the DevOps Rex in Paris here recently, and there's one going on in Oslo right now, like literally today. And I'm from Minneapolis, Minnesota, so I am one of the speakers who traveled a little bit to get here. But I do enjoy coming to Paris whenever I have an excuse, so thank you, Antonio, for giving me an excuse. So I feel like back to the idea of the endless present. It does feel a little bit like, even when it's your job, keeping up with today's technology can feel totally impossible, right? So like you blink and at least half the stickers on that laptop feel like they're legacy now. And the cat's like, the laptop's still warm, it's fine. But every time you turn around, something changes, or like you wake up and somebody has acquired somebody else and you're just like, what's happening? What's happening to the world? And it's okay if you feel that way. Everyone feels that way. Even if your job is literally to keep up with things going on in containers and Kubernetes, which is mine, and you still feel like things are changing constantly. It is okay. Like, you're not required to take whatever's on the front page of Hacker News and YOLO it out into production immediately. It's okay. It's probably fine. You don't have to do that. But that said, like, time also passes a lot faster than you think. Like, it blows my mind to think about the fact that Kubernetes has been around for 4 years. And if you're thinking to yourself, wait, what? Because that's the new shiny that I haven't even gotten to the new shiny right before that yet. And you're telling me Kubernetes is almost legacy? It's like, yes, I'm sorry. I mean, it's going to be around for a long time, but the world moves very, very fast, and the tech world even more so. So, and this is not me making a proclamation about the inevitability of one particular orchestrator. I'm just saying that the present is kind of hard to pin down because it just keeps on slipping into the future, like the saying goes. I also think that there's this idea that orchestrating complex systems makes them super simple and easy, right? Like, as soon as we go to microservices, everything is solved. Like, stick a fork in it, go home, we're done, right? We've solved technology. Except maybe not. Because a former boss of mine, Tim Gross, likes to say that we can't get rid of complexity. All we can do is move it around. We have conservation of complexity, but I think we were discussing this the other day, and my spouse, Joe, said that complexity is neither created nor destroyed. I'm like, yep, absolutely, because it makes a lot of sense when we go to microservices to say, oh, hey, we can do independent deployments. Like, we no longer have to worry about being held back on our fast iteration of this particular service just because another part either can't take a new dependency or can't be deployed today or that sort of thing. It's like, yes, but like, okay, say you replace IPC by transient network failure. Like, it hasn't necessarily gotten better, it's just moved around. So I also think that we have to have our tech cliche bingo. So when we're talking about this kind of complexity, we also need to talk a little bit about cap theorem. And I think that it's actually a more limited space that than you might think, and more on that in just a second. But I do think it's important to realize that it's been pretty well established that when they say pick two, they mean pick one, right? You get to choose between consistency and availability because, like a distributed systems expert and my coworker at Microsoft, actually, Katie McCaffrey puts it, physics and math, you don't get to pick not to have partitions. Like, you have to plan for them because and again, I'm talking specifically about distributed systems because obviously if we've distributed all of our complexity across a bunch of microservices, congratulations, you have a distributed system. And so you've now moved into the realm of academic computer science and all of the exciting failure states that you get to see there. I think if you want to read more about CAP theorem, I recommend a blog post that Julia Evans just wrote. It's quite good. It goes into a lot of detail specifically about the limited scope of CAP theorem. I am going to talk a little about CAP theorem, but go ahead and read this if you want actual technical detail because I'm basically going to use it as a metaphor. I'm going to say, and this, by the way, this is a picture from my hometown, from Minneapolis. We live in a land of 10,000 tech cliches, apparently, because we have clouds and containers and silos and all of those things. We have a green field there. The slow-burning tire fire that is Prod is somewhere off to the left, you know. So we have, when we're looking at CAP theorem, the idea of CAP theorem being consistency, availability, you know, partition or fault tolerance. Let's talk about consistency a little bit. Again, not necessarily technical. Go to Julia's post for that. But as a framing device, first of all, like my colleague Jess Frizzell was just keynoting at GitHub Universe. By the way, to the Red Hatters in the room who are terrified, like Microsoft acquired GitHub and that just got finalized and everything was fine. So it's probably fine. But my colleague Jess likes to say that containers aren't real, which is funny because if you know Jessie Frizzell, she's very well known for her work at Docker and her work in the container space. But she's right when they say they aren't a real thing because they're actually just C groups and namespaces. But at the same time, people don't get excited about C groups and namespaces and think about those changing their life. So we have to have a little bit more hype than that. But the nice thing about containers, I've used them myself in production. And everybody says, it's 2018, we all use containers in production. And I'm like, I joined an adorable startup. I joined in 2014, but they started using Docker in production in October 2013. When I think at that time, we'd have to check the Wayback Machine to be sure. But I think in 2013, the main thing on Docker's website was giant letters in Blink saying, under no circumstances should you use this in production. And the startup I joined was a streaming video company. It was like Netflix, only much smaller and mostly Korean soap opera. And got acquired by Warner Brothers, so I guess sometimes YOLO works out. But the reason that they went to Docker in production so early is to have more consistent deployments, more repeatable processes. And I think when we're thinking of consistency, containerization makes a huge difference, right? Again, you're distributing your logic and your state all over the place. You definitely don't want things to slip through the cracks. So I think the rise of more user-accessible containerization, because, I mean, some of us used Solaris zones and FreeBSD churret jails ages ago, and we're like, containers aren't new. And it's like, yeah, but they're a lot more accessible to a lot more people, which is why they've gotten so popular. And I think that, yes, containers solve all of these problems that you run into when trying to reproduce your deployments. I think it's also really important to remember that they will also create problems for you. This is, again, the conservation of complexity thing. And again, this is like the anti-hype. We're going to have the anti-hype talk because they give you something new to manage. They give you new failure modes, and they give you new things you have to worry about, like, you know, exactly how you're generating the images and how you're making sure that you're not shipping around, you know, absolutely enormous hundreds of megs of container images with the full OS there. And then, hey, I know nobody ever wants to think about security, but it's an afterthought that you don't want to worry about. But I assure you that if you're patching your underlying host OS and you're not patching the OS that's in the container image, you're going to have a bad time sooner or later. So like it's a tool. It doesn't magically make everything awesome. And I think it's also important to consider, like, when you're deciding to orchestrate a bunch of containers, say with something like Kubernetes, you're going to have so much YAML, like absolutely so much YAML. And I feel like there needs to be, I run a Kubernetes workshop. I'm actually running it in London on Wednesday morning, so I'm just here today. But there's I like to say content warning, trigger warning for YAML. Like if you find YAML upsetting and you're going to use Kubernetes, there's so much YAML. I think it's useful to realize then, and I am going to point to a few open source projects here, because Helm is a good example of, you have so much YAML to manage. Well, I mean, you can bundle all that YAML up, and this, by the way, it's an open source project. Some of my colleagues at Microsoft are on the project, but there are other people on the project as well, and it is now a CNCF incubating project too. So presumably you'll see a lot more from that. But the kind of stuff you can do with a tool like this is managing a lot of that complexity. So you can have a chart where you're providing like a definition of what goes with this app, be able to install it repeatably, kind of a single point of authority of what's in this version. And you gotta, I spent 15 years on call for production, and if some of you have been on call for production, you know how it goes when you're trying to do a rollback, which is, by the way, like, yes, I mean, Helm does make going back to an old version of something easier, though I think rollbacks are kind of a lie, because you don't actually have a time machine. So what you're doing is you're rolling forward to something that you hope is a lot like the past when things worked and you weren't sad. That's how I feel about rollbacks. But the updating you can do is like more in-place updating with like custom hooks, and the sharing piece I think is really valuable. So say you want to, like in the workshop I'm going to be running in London later this week, you want to install Prometheus. If any of you have installed Prometheus, you know that there's a little bit of work to getting it all ready, and you want your installation to turn out the same as last time, and hopefully the same in staging as in production. And that's the sort of thing that you can just bundle all the configuration together and ship it. And then, install old versions. I don't like the word rollback, but install old versions. This is an example of the sort of thing that, and you're like, a YAML management tool, excellent. Well, yeah, unless you have all the YAML you're trying to manage by hand, just throwing it in GitHub somewhere and tagging it. Like, this makes it a lot easier, right? I'll post the slides online later, so you don't have to try to take a picture of these links and then type them in slowly. But I am excited because I'm going to help PM the Helm 3 release, and that is coming up, and it's really exciting. So it's a lot of, this is kind of one of those, it's not a Perl 6 someday maybe. It's actually like we are going to Helm 3, and there are some things that are different, and we're really interested in the community input on that. Okay, so that's keeping things consistent. Then there's availability. I think it's really valuable to think about when we're running stuff in production, we really want it to stay up. I mean, that's kind of the reason we're running it. And I think, again, Kubernetes is one orchestrator out there. It's valuable to look at the kind of characteristics you want in your orchestration platform, whether or not you're using this specific one. I was just at HashiConf last week, and like, a lot of people are doing this sort of thing with Nomad. People do this sort of thing with Mesos. Like, there's a lot of choices out there. But I think you want these three characteristics, right? Like, you want it to be able to run in the cloud or clouds of your choice. Like, I work for Microsoft now, but I spent a couple of years working for Pivotal, and a lot of customers, like the most common word we would hear is multi-cloud, because customers want choices. You also want to be able to use something extensible, and that's one place where open source is really valuable, right? Because we've all been in a situation where a vendor gives us something and we're like, that's about 80% of the way there, but we really need to change it to be right for our use case. So like, it's really important to pick, obviously, software that you can work with in that way. And then I think all of the auto remediation stuff is really important, because anything you're going to run at scale in production is going to experience unexpected circumstances. I mean, you might inject failure to test things or to make them more resilient, but you're definitely going to experience things that you weren't expecting. So like having you get paged to like add nodes or whatever is not, it's a non-starter. You don't want that. So you definitely want to look at things like this. And again, other orchestrators other than Kubernetes can do this sort of thing, but it's a pretty good idea. And this is just a little bit more of the kinds of stuff you can do that I think it's the one I find the most interesting here is the seamless rollout stuff. So anytime you're using something like this, you're going to care about that because people like to say zero downtime, and I'm like, it sounds unrealistic, but it's also what everyone expects now. So it's important to have our tools be able to do this sort of thing. So like another open source tool I'm going to point you to, and I won't go into tons of detail about it. Again, the slides will be online, but Draft, it makes it easier to do app development and deployment with Kubernetes. So it's another open source tool that makes this sort of thing easier. Again, like concrete stuff you can use right now. And Brigade, if you saw like all of the GitHub Actions announcements at GitHub Universe, Brigade kind of has a parallel evolution there. GitHub is part of Microsoft now, so I imagine that we'll be working together on this kind of thing. But the idea is event-driven scripting. So like if just writing and shipping some YAML isn't enough and you want to actually have some code that goes along with it, you can write it in JavaScript. So, then trigger based on events. So that's, again, it's worth closely watching. And another tool in that space that I'll point you to, and again, this is all about making things according to your choices. A lot of people have like their own data center where they have lots of resources, but then maybe they want to burst for some things to the public cloud. And I think it's worth looking at the virtual kubelet because this lets you add arbitrary resources to your Kubernetes cluster and have it look like they're part of the cluster. So, and again, these are all free open source on GitHub projects that are probably valuable for some of your needs. Kind of the TLDR then on the care and feeding and orchestration of containers is I always caution people when they get started on like their Kubernetes initiative, and a couple years ago it was their Docker initiative and whatever. I'm sure for a while it was their unikernel initiative, but that didn't really happen. So, but when people get excited about that, I always caution them to think like, the first question is always, what problem are you trying to solve? Because like, sure, you probably want to Kuber some netties. That sounds awesome. It'll be definitely great for your resume, and maybe it'll be great for your organization, but it's really important, again, from the social technical side, it's really important to make sure that you're not introducing a bunch of incidental complexity into your stack for no reason. Like if you're not going to get enough benefit from it, then don't do that to yourselves. I would say Kubernetes right now is a place where I would watch out for resume-driven development. Like figure out why somebody wants to do it. Figure out why you want to do it. Okay, and then the last thing, in the case of, we're here and we're many time zones away from like where I live, and I think I talked to a bunch of people at the speaker dinner who work on teams that are split across time zones in various countries. And I think it's really important in terms of our composition of our teams and our decision making that we don't end up blocking on people who are not going to be awake for 10 and a half hours or whatever. I took this picture in Bangalore because at Target in Bangalore, they are 10 and a half hours away from Target headquarters in Minneapolis. And it's interesting, but then it's also distressing because it's like, oh, we got to make sure people are empowered. Sorry, I didn't click to the next one. I was looking at the wrong one. But we got to make sure people are empowered to make decisions, not based on, having to send everything back to a central command and control, which makes no sense. We also, when we're talking about distributed systems, this also applies to again, we have to put all of the tech buzzword bingo in here. Talking about Conway's law, people like to look at Conway's law and think that it means that like you need to spin up a new team every time you have like a new microservice initiative, and that's not really. I don't think that's really what it means. And if you're not familiar with Conway's law, it's wrote in the 1960s. Mel Conway is still alive today and posting on Twitter, which is amazing, by the way. You should go read his Twitter. But in the 1960s, he wrote a paper called How Do Committees Invent? And I don't know why anyone read it based on that title, but it's actually quite good. And he buries the lead. Like the interesting stuff is pretty far into the paper. I feel like if it were written today, this would be like a BuzzFeed listicle, but it's not saying your org has to look like your Death Star microservices diagram. It just says you need communication across the organization. And that communication is the most important word in Conway's Law. And it's all about the when you have microservices, a lot of times organizations get excited about those because that means that they can ship without worrying about that other team. And that's true, but they need to worry about, are they taking a dependency, or are they going to have breaking changes? Are they going to make other teams incur breaking changes? Like, what exactly do the interactions look like? And you have to talk to each other about that. Having a cross-functional team is great, but then they need to talk to people in other teams to make sure that they don't cause problems. And there's no substitute for experimentation in your real production environment. This quote is from Charity Majors, who runs a company called Honeycomb, and that is one example of an organization out there doing this sort of thing. The idea of being able to actually see all of those unknown unknowns that you don't know to look for, super important when you're trying to troubleshoot in a distributed environment where you're not sure which thing of the N things is causing this failure. Like, you can page on that one service, but that doesn't necessarily give you any insight as to why it's having problems. So it's really important, I think, when you're building microservices to make sure you're building them in a way that you can observe and get information out of them. And there is in the Kubernetes ecosystem, there is an open source project, Cached, that makes it a little bit easier to look at those event-based tasks, like the brigade stuff that we talked about, so that you can get more insight quickly into why did this fail? Because you're like, great, it's down, but I want to know why it failed. So that's it gives you a view of your event pipelines, so like failures logs. Again, there's a lot of commercial tools out there that do this, but especially if you're just starting to set something up, your boss doesn't want to hear that you just spent all of the money and now we're going to see if we can do any of these things. Like, let's start with some open source projects to do a proof of concept before we do anything else. So yeah, if your Kubernetes system is well behaved, which, hopefully, you're going to have good insight into and information about this sort of stuff. Especially, again, like the service discovery, the health monitoring. It didn't alert me. Why didn't it alert me? I'm always the most suspicious of like something new that does not alert in any way. So at this point, you're probably thinking, okay, so computers are easy, right? And that people stuff, that cross-team collaboration, that's hard. And I'm like, no. That's totally a lie, right? I gave a talk with that title as a provocative lie a number of times, because really what we're doing is we're building really complex systems, and we need to talk to each other to build them right. Because all of these complex systems, I got news for you. Like, your banks and your airlines and your governments are all trying to Kubernetes. So like, this just got really real because I have to fly on those planes, and I want that to go well. So I feel like there's a lot of places in our organizations and places in our industry that it can feel really lonely, and it can feel really confusing, and it can feel like we're scrambling and we're lost, and we're going to be the sad snowman melting because we didn't update everything, and we probably have to hurry and rush. And I think being willing to change is really important. And, Deming's not wrong when he says, like, it's not necessary to change because survival is not mandatory. But I don't want that to scare us. I want it to inspire us. I want us to notice and pay attention to this. This is my pinned tweet, and this is not the kind of change that I was expecting to see. Because I'm like, I've literally never owned a Windows computer. And I was like, when I joined Microsoft, one of the things I talked to them about was like, I'm a Unix person, all right? I'm a Linux person. I ran FreeBSD at home until 2015. Like, and then I finally was like, I can just use the cloud. But I think that it's really important for when you're talking to people who don't want you to change things, who don't want you to move them into the now that we're all trying to live in. The way we do things is basically just processes that are the scar tissue of past failures. We don't have to. We can look at the past, learn from it, but we are operating in the now, and we can. And I think that it's valuable to realize that if an organization like Microsoft can change, yours probably can too. Azure is more than 50% Linux now, all right? Like this is the world we live in now, which by the way, from that, I think we can conclude that this might be the darkest timeline, but it has some bright moments. It has some good stuff. And I think that it's what's exciting about it is that this is not the world that I thought we were going to live in. I definitely wasn't going for climate change geopolitical disaster as my dystopia that I thought we were going to end up in. But at the same time, I'm really encouraged by all of the collaboration across the industry. So especially, and I do have an agenda, and the agenda is all of those open source projects I mentioned. It would be great if all of you would get involved. And, open issues, like send pull requests, and basically, like, please help us. Pull requests accepted. See you on GitHub. Thanks.